Hello students, welcome to Showup Sir classes, and in this particular video lecture we'll be solving the sums from AP Calculus, this AB exam. Okay, so this is as you can see in the section, and these are all multiple choice question. And just let's go through this instruction. What is this at a glance? So the total time will be 1 hour and 45 minutes. So in this total number of question will be 45. So in the first part we will solve the part A, where we will solve the 30 MCQ question and time is 1 hour, and for the part B we have to solve the 15 questions, the objective questions, and the time will be 45 minutes. Okay, so this will be the structure of this AP Calculus AP exam. And now let's move to the question number 1 of part A. So the question 1, you can see over here, is given that integral of x squared by 4 dx. Okay, so before moving into the details of in finding the answer, first we will go through the topic. So the topic of this question is from the finding antiderivative, right, and indefinite integrals. So these are the topic, and it is basic rules and notation. Now let's look at the sum given. So here it is simple, that integration of x square by 4. So by the power rule of this antiderivative we can solve this. So what is the power rule is telling? So we have this, where it is, if we do the integration of this x to the power n, it will be x to the power n plus 1 by n plus 1. So simply if we do this over here, so integration of x square by 4 dx, so if we take this 1 by 4 common, so we have integration of x square dx, and then it will be simply 1 by 4 this x cube by 3 plus c, right? So c will be the constant of integration. So from here this will be the x cube by 12 plus c. So here from you can see that the correct option is nothing but the option B. Okay, so the option A here, it is incorrect, because this is the derivative of x squared by 4, not the antiderivative. Option C, you can see this is also incorrect. This response would result if the power rule for antiderivatives was not applied correctly. So, and the option D is also incorrect. So this is these two options. So the only option correct over here is option B for question number 1. So question number 2, it is saying that which of the following is an equation of the line tangent to the graph of y equal to cos x at x equal to pi by 2. Okay, so first the topic, name of this topic is defining the derivative of a function and using derivative notation. Okay, derivative notation. So this is the topic. Now here it is given that the which one of these the following is an equation of the line tangent to the graph y equal to cos x. So y equal to cos x is the equation, and the slope of the tangent line is nothing but the value of the derivative, right? This will be the value of the derivative at x equal to pi by 2, right? This is over given over. So now the what will be the, if we write it in this form, the slope will be dy dx, right? So it will be equal to minus of sine x when this, now dy dx at x equal to pi by 2, it is simply minus of sine pi by 2, which means it is minus 1, right? So at x equal to pi by 2, y equal to 0, equal to cos pi by 2 is equal to 0, right? So the equation, so an equation of the, so how to write the equation? So an equation of the tangent line, so an equation of the tangent line, the at the point, so what are the points? So x is pi by 2 and y is 0, so it will be therefore y equal to minus of 1, that is the slope we have given, x minus pi by 2 plus 0, right? So now from here we can get that it is nothing but y equal to minus x plus pi by 2. So if we check with the correct options over there, so it will be, the correct option will be option C, minus x plus pi by 2. So in question number 3, we have to find the dx of this particular function 2 of sine root x whole square. So first we understand this, the topic. So this topic is from the chain rule. Now we will see how to solve this particular sum. So for this particular problem, we have to apply the chain rule. Okay. Twice, right? Because we have this 3 functions over here. Because we have the composition of 3 functions over here. So that's why you have to apply the chain rule twice. So now d of dx is, so let's write this function. D of dx is 2 the sine of root x whole square, this one. So from here if we do the, so it will be 2 sine root x, then we have this ddx of sine root x, right? So it will be simple 2 of sine root x, then we will have this cos of root x, then again we have this ddx of root x. So these are the 3 steps. So simply we can do this, 2 of 2 sine of root x, it will be cos of root x, and ddx of root x is 1 by 2 root x. So the final answer will be 2 sine x, sine of root x, cos of root x by root of x. So if we check with this option, so the correct option here is D for question number 3, 2 sine root x cos root x by root x. So in the question number 4, we have to this integration of x square plus 1 by x cube plus 3x minus 5 to the power cube dx. So the topic for this question is nothing but the integration using substitution. Okay. So first of how to start with this. So let us substitute this u be given as x cube plus 3x minus 5. Okay. So we have this u. Now if we do this du dx, so it will be 3x square plus 3. Now if we take this 3 out of common, so 3 of x square plus 1. Now if we do this dx over here, so du by 3x square plus 1. Good. Now substituting for this value x cube plus 3x minus 5, okay, and for dx we will have this integration. So if we write the integration as this, x squared plus 1 by x cube plus 3x minus 5 to the power cube dx, it can be simply written as integration 1 by u cube 1 by 3 du, because this x squared plus 1 will cancel out, right? So if we do the integration, so it will be 1 by 3 minus of 1 by 2u square plus c. So if we put the value of this u over here, so we will have 1 by 6 by this 1 upon x cube plus 3x minus 5 whole square plus c. So if we check with these options, so which will be the correct one? So D is the correct option for question number 4. So the question number 5 is saying that the function f is given by fx of 4x cube minus x to the power 4. On what intervals is the graph of f concave up? So first we have to go through from which topic the question is. So it is the determining concavity, determining concavity of functions over their domains. So this is the topic. Now let us start to solve this problem. So so we have to find up to on what intervals is the graph of the f concave up. Okay, so the graph of f will be concave up on intervals where this f of this double derivative of f dash x double prime x is greater than 0. So we have this f prime of x will be 12x square minus 4x cube, right? So what will be the f of double prime? F of double prime of x is equal to 24x minus 12x square, right? So you can just do over here this 12 of this, you can just 12x, so it is nothing but 2 minus x. Okay, so from here you can see that the graph of f double prime, this of the second derivative of this function, is a parabola, right? So it is this type of a parabola which is the opening downward, is opening downward with zeros at, so a 0 will be at which position? At x equal to 0 and x equal to 2. So if you do this equal to 0, so we have it must be greater than 0 over here. So for x equal to 2 and x equal to 0, we have these zeros, right? So therefore this f double prime of x, the double derivative of x, will be greater than 0 on the interval, on which interval? On the interval between the two zeros, that is between 0 x 2. So this will be the interval in which the graph of f concave up. So the correct option for question number 5 is C, 0, 2 only.